1888, Washington, D.C. The mathematical crisis facing the United States Census Bureau would have been impossible for European statistical experts to comprehend. 63 million Americans needed counting for the 1890 census. Using proven European hand-counting methods, completion would require 13 years, longer than the constitutional requirement for the next count. Through the marble halls of government buildings, census officials whispered about mathematical impossibility. European-trained statisticians insisted that mechanical devices lacked the judgment for proper statistical interpretation. Human clerks with ledger books represented the pinnacle of data processing, methods perfected across smaller European nations for decades. Then Hermann Hollerith, a 28-year-old son of German immigrants, proposed something that defied everything European statistical tradition considered reliable: electric tabulating machines, punch cards read by pins and mercury, electricity doing the counting instead of human hands. The Census Bureau announced a competition. 3 methods would process identical data from St. Louis. Winner takes the $5 million contract. Hollerith's European competitors used established hand-counting systems with mechanical assists. The results would shatter every assumption about what machines could never accomplish. Because when American engineering chose reliability over European theory, they built something that would still be calculating 60 years later. The morning of October 15, 1888, brought unseasonably cold air to the Census Bureau's testing facility on F Street. Hermann Hollerith arrived at 7:30, carrying a leather satchel containing the punch cards that would either validate 3 years of engineering work or confirm European statistical experts' predictions about American mechanical folly. The testing room held 3 stations, 2 equipped with the traditional European hand-counting systems that had successfully processed census data across smaller nations for decades, and 1 containing Hollerith's electric tabulating machine, its 40 electromagnetic dials gleaming under gaslight. Dr. Francis Walker entered precisely at 8 o'clock, followed by 6 European-trained statisticians who had traveled from universities in Boston, Philadelphia, and Baltimore to witness what they anticipated would be a definitive demonstration of mechanical calculation's limitations. Walker's reputation rested on statistical methods he had learned during his European education, techniques that relied on trained clerks making careful tallies in ledger books, with multiple verification steps to ensure accuracy. These methods had proven themselves across European nations where populations rarely exceeded 20 million people. The test parameters were straightforward. Each system would process identical data from the 1880 St. Louis census. 10 sawi. 1,000 individual records containing age, occupation, birthplace, and family status information. European method. Number 1 employed 12 clerks working in teams of 3, with each team responsible for specific data categories. European method number 2 used 8 clerks with mechanical assists, hand-cranked adding machines, and pre-printed tally sheets that reduced manual calculation errors. Both systems represented refinements of techniques that had successfully handled European census operations for generations. Hollerith's system operated on entirely different principles. Each census record was represented by a single punch card measuring 6 5/8 inches by 3 1/4 inches, dimensions chosen specifically to fit existing paper currency storage boxes used by banks and government offices. The cards contained 210 possible punch positions, with different combinations representing various demographic characteristics. A specialized pantograph punch allowed operators to create holes corresponding to each person's census information in approximately 45 seconds per card. The tabulating machine itself contained no moving parts except the electromagnetic counting dials. When an operator placed a punched card on the machine's reading surface and pressed down, spring-loaded pins descended through the card holes into small mercury baths below. Wherever a hole existed, electrical contact between pin and mercury completed a circuit, advancing the appropriate counting dial by 1 unit. The entire reading process required less than 3 seconds per card. Walker announced the competition's commencement at 8:15. European method. Number 1 began with systematic efficiency. Clerks arranged in precise formations around large tables, each equipped with standardized ledger books and steel-nibbed pens. The head clerk called out data categories while teammates made careful marks in designated columns. European method number 2 operated with similar organization, though clerks used mechanical adding devices to verify their calculations at regular intervals. Hollerith stationed himself beside his tabulating machine with Mary Lamb, his most experienced card punch operator. Lamb had processed over 1888, Washington, D.C. The mathematical crisis facing the United States Census Bureau would have been impossible for European statistical experts to comprehend. 63 million Americans needed counting for the 1890 census. Using proven European hand-counting methods, completion would require 13 years, longer than the constitutional requirement for the next count. Through the marble halls of government buildings, census officials whispered about mathematical impossibility. European-trained statisticians insisted that mechanical devices lacked the judgment for proper statistical interpretation. Human clerks with ledger books represented the pinnacle of data processing, methods perfected across smaller European nations for decades. Then Hermann Hollerith, a 28-year-old son of German immigrants, proposed something that defied everything European statistical tradition considered reliable: electric tabulating machines, punch cards read by pins and mercury, electricity doing the counting instead of human hands. The Census Bureau announced a competition. 3 methods would process identical data from St. Louis. Winner takes the $5 million contract. Hollerith's European competitors used established hand-counting systems with mechanical assists. The results would shatter every assumption about what machines could never accomplish. Because when American engineering chose reliability over European theory, they built something that would still be calculating 60 years later. The morning of October 15, 1888, brought unseasonably cold air to the Census Bureau's testing facility on F Street. Hermann Hollerith arrived at 7:30, carrying a leather satchel containing the punch cards that would either validate 3 years of engineering work or confirm European statistical experts' predictions about American mechanical folly. The testing room held 3 stations, 2 equipped with the traditional European hand-counting systems that had successfully processed census data across smaller nations for decades, and 1 containing Hollerith's electric tabulating machine, its 40 electromagnetic dials gleaming under gaslight. Dr. Francis Walker entered precisely at 8 o'clock, followed by 6 European-trained statisticians who had traveled from universities in Boston, Philadelphia, and Baltimore to witness what they anticipated would be a definitive demonstration of mechanical calculations' limitations. Walker's reputation rested on statistical methods he had learned during his European education, techniques that relied on trained clerks making careful tallies in ledger books, with multiple verification steps to ensure accuracy. These methods had proven themselves across European nations where populations rarely exceeded 20 million people. The test parameters were straightforward. Each system would process identical data from the 1880 St. Louis census. 10 Sawi. 1,000 individual records containing age, occupation, birthplace, and family status information. European method. Number 1 employed 12 clerks working in teams of 3, with each team responsible for specific data categories. European method number 2 used 8 clerks with mechanical assists, hand-cranked adding machines, and pre-printed tally sheets that reduced manual calculation errors. Both systems represented refinements of techniques that had successfully handled European census operations for generations. Hollerith's system operated on entirely different principles. Each census record was represented by a single punch card measuring 6 5/8 inches by 3 1/4 inches, dimensions chosen specifically to fit existing paper currency storage boxes used by banks and government offices. The cards contained 210 possible punch positions, with different combinations representing various demographic characteristics. A specialized pantograph punch allowed operators to create holes corresponding to each person's census information in approximately 45 seconds per card. The tabulating machine itself contained no moving parts except the electromagnetic counting dials. When an operator placed a punched card on the machine's reading surface and pressed down, spring-loaded pins descended through the card holes into small mercury baths below. Wherever a hole existed, electrical contact between pin and mercury completed a circuit, advancing the appropriate counting dial by 1 unit. The entire reading process required less than 3 seconds per card. Walker announced the competition's commencement at 8:15. European method. Number 1 began with systematic efficiency, clerks arranged in precise formations around large tables, each equipped with standardized ledger books and steel-nibbed pens. The head clerk called out data categories while teammates made careful marks in designated columns. European method number 2 operated with similar organization, though clerks used mechanical adding devices to verify their calculations at regular intervals. Hollerith stationed himself beside his tabulating machine with Mary Lamb, his most experienced card punch operator. Lamb had processed over 50,000 cards during system development and could maintain 80 cards per minute indefinitely. As she fed punched cards through the tabulator, electromagnetic dials advanced with mechanical precision, age distributions, occupational categories, birthplace statistics accumulating automatically without human calculation or transcription errors. By noon, clear patterns had emerged. European method number 1 had processed roughly 1,500 records, with clerks maintaining careful accuracy through multiple verification steps. European method. Number 2 had completed nearly 2,000 records, benefiting from mechanical calculation aids that reduced arithmetic errors. Hollerith's system had tabulated over 4,000 records, with electromagnetic counters providing instant totals for any data combination Walker requested. The European-trained observers grew increasingly uncomfortable as afternoon hours revealed the full scope of Hollerith's mechanical advantage. Where traditional methods required clerks to manually cross-reference information, determining, for example, how many German-born blacksmiths lived in specific ward districts, Hollerith's system provided such analysis instantly. The tabulating machine could sort punched cards into any desired categories, then retabulate the sorted groups to produce detailed statistical breakdowns that would require days of manual calculation using European methods. At 5:45, Walker called for preliminary results. European method number 1 had processed 4,200 records in 144 and 1/2 hours of total clerk time. European method. Number 2 had completed 4,800 records in 100 and 1/2 hours. Hollerith's tabulating system had processed all 10,000 records in 72 and 1/2 hours of operator time, nearly twice as fast as the best European method. But the competition's second phase would prove even more decisive. Walker announced that each system must now perform detailed statistical analysis of their processed data, cross-tabulating occupational categories with birthplace information, age distributions by ward districts, and family size correlations with economic indicators. Such analysis represented the true value of census data for government planning and policy decisions. European statisticians began the laborious process of manually reviewing their ledger entries, creating new tally sheets for each requested correlation. European method number 1 required 44 and 1/2 hours to complete the analytical phase. European method number 2 needed 55 and 1/2 hours, despite mechanical calculation aids. The European observers anticipated that Hollerith's system, having produced raw tabulations quickly, would now reveal its limitations when confronted with complex analytical requirements that seemed to demand human judgment and flexibility. Instead, Hollerith demonstrated the tabulating machine's most revolutionary capability. By sorting punched cards into different combinations and retabulating the sorted groups, his system produced every requested statistical analysis in 5 and 1/2 hours, 10 times faster than European methods. The electromagnetic counters provided precise totals for any data relationship Walker could devise, eliminating the manual calculation errors that plagued traditional statistical work. The testing room fell silent as Walker announced the final results. European experts demanded verification, certain that mechanical systems could not possibly match human accuracy and statistical interpretation. But repeated testing confirmed the tabulating machine's precision, not a single counting error in 10,000 processed records. The $5 million contract signed on November 23, 1888, represented the largest mechanical calculation purchase in American government history, But Hollerith understood that winning the competition had been the simple part. Now his tabulating machines would face the unprecedented challenge of processing 63 million individual census records, nearly 3 times larger than any statistical operation ever attempted by any nation. In his Georgetown workshop, surrounded by blueprint tables and precision measuring instruments, Hollerith refined the engineering specifications that would either revolutionize American data processing or collapse under the weight of continental-scale mathematics. Each punch card required exact dimensional tolerances to ensure reliable mechanical operation. The 6 5/8 inch by 3 1/4 inch specifications weren't arbitrary. Hollerith had tested dozens of size variations before discovering that existing paper currency storage systems used by banks and government offices could accommodate cards of precisely these dimensions. More importantly, cards of this size provided sufficient surface area for 210 punch positions while remaining small enough for rapid manual handling. The card stock itself demanded careful selection, too thick, and the spring-loaded pins couldn't penetrate cleanly. Too thin and repeated handling would cause tears that jammed the tabulating mechanism. The tabulating machine's design reflected Hollerith's mining engineering background and his obsession with mechanical reliability over pure speed. The central housing contained 40 electromagnetic counting dials, each consisting of a numbered wheel connected to an electromagnet and ratcheting mechanism. When electrical current flowed through the electromagnet, a lever advanced the counting wheel by exactly 1 unit. The genius lay in the system's electrical simplicity. No complex circuits, no delicate timing mechanisms, just direct current flowing through mercury-filled contact baths when spring-loaded pins completed connections through punched holes. Hollerith's mercury switch design eliminated the mechanical wear problems that plagued other electrical counting devices. Traditional electrical switches required metal-to-metal contact that created sparks and oxidation, leading to connection failures after thousands of operations. Mercury provided a self-cleaning, non-oxidizing contact medium that could handle millions of electrical cycles without degradation. Each mercury bath contained precisely enough liquid to ensure reliable pin contact without creating spillage during normal operation. The spring-loaded pins themselves were constructed from tempered steel with carefully polished points that could penetrate cardstock cleanly without creating ragged holes that might jam subsequent readings. The punch mechanism required equal engineering precision. Hollerith developed a specialized pantograph that allowed operators to create perfectly round holes in exact positions by following printed templates. The pantograph's leverage ratio reduced the force required for punching while ensuring consistent hole sizes. Too small, and pins might not make reliable mercury contact. Too large and card strength would be compromised. Experienced operators could punch a complete census card in 45 seconds, but the Bureau's timeline demanded processing speeds that would test human endurance limits. Mary Lamb supervised the training program for Census Bureau punch operators, establishing procedures that would maintain accuracy during months of continuous operation. Each operator learned to punch cards by following standardized templates that corresponded to different census questions, age ranges, occupational categories, birthplace designations, family relationships. The key insight was that operators didn't need to understand statistical significance, only to translate written census information into consistent punch patterns. This division of labor allowed rapid training of personnel who could maintain production rates without requiring extensive mathematical education. The tabulating process itself represented a marvel of electromechanical coordination. Operators placed punched cards on the machine's reading surface, a brass platform containing 210 spring-loaded pins arranged in precise grid formation. Pressing down activated all pins simultaneously, with each pin descending through its corresponding card position. Where holes existed, pins continued downward into mercury baths, completing electrical circuits that advanced appropriate counting dials. Where no holes existed, pins stopped at the card surface, preventing electrical contact. The entire reading cycle required less than 3 seconds, with electromagnetic counters providing instant totals visible through glass windows on the machine's front panel. Hollerith's sorting box innovation solved the complex analytical challenge that had impressed European statisticians during the competition. The sorting box contained 24 separate compartments, each connected to the tabulating machine's electrical system. By configuring the machine to direct electrical current to different compartments based on punch patterns, operators could automatically sort cards into desired categories: all German immigrants in one compartment, all blacksmiths in another, all residents of specific wards in a third. This mechanical sorting eliminated the manual card handling that would have made complex statistical analysis impossible at continental scale. The system's reliability depended on conservative engineering principles that prioritize continuous operation over maximum speed. Hollerith deliberately avoided complex mechanical components that might fail under sustained use: no gears that could strip teeth, no belts that could break, no steam pressure that could create explosive failures, just springs, pins, electrical circuits, and mercury baths, components that could operate indefinitely with minimal maintenance. The electromagnetic counting dials used simple ratcheting mechanisms that advanced one position per electrical pulse, with no possibility of mechanical jamming or timing failures. Quality control procedures ensured accuracy throughout the processing cycle. Each punched card underwent verification by a second operator who checked punch positions against original census forms. Tabulating machine operators performed test readings on sample cards before processing each new batch, confirming that all electromagnetic counters advanced properly. Statistical supervisors compared preliminary totals against expected population estimates, investigating any discrepancies that might indicate systematic errors. This multi-stage verification process provided accuracy guarantees that exceeded European hand-counting methods while maintaining unprecedented processing speeds. By spring 1889, Hollerith had delivered 43 tabulating machines and 56 card punch stations to Census Bureau facilities across Washington. The mechanical specifications that had seemed impossible to European experts were proving themselves through continuous operation, processing test data with reliability that traditional methods couldn't match while preparing for the 63 million card challenge that would either validate American mechanical innovation or expose its fundamental limitations. The 1890 census officially commenced on June 2nd with nearly 5,000 enumerators fanning across the continental United States, each carrying standardized forms designed to capture information that Hollerith's tabulating machines could process mechanically. Unlike previous census operations that relied on summary tallies prepared by local officials, this count would document every individual American on separate punch cards, a logistical undertaking that European statisticians had declared mathematically impossible. Census Bureau supervisors established processing centers in Washington, Baltimore, and Philadelphia, with each facility equipped with banks of tabulating machines that would either validate American mechanical innovation or reveal its catastrophic limitations when confronted with continental-scale data. The punch card operation began in earnest during August 1890 as completed census forms arrived from field enumerators. Mary Lamb supervised 300 trained operators working in shifts around gaslight-illuminated halls, filled with the rhythmic clicking of pantograph punches, creating precise holes in card stock. Each operator maintained production quotas of 70 to 80 cards per hour, translating handwritten census information into standardized punch patterns that corresponded to age ranges, occupational categories, birthplace designations, and family relationships. The cards accumulated in wooden storage boxes originally designed for paper currency, with each box holding exactly 1,000 completed cards, organized by enumeration district. By September 15th, over 12 million cards had been punched and verified through the dual operator checking system that ensured accuracy rates exceeding 99%. The tabulating machines operated continuously during daylight hours, with operators feeding cards through brass reading platforms, while electromagnetic counters accumulated population totals visible through glass windows. The mechanical precision that had impressed European observers during the St. Louis test now faced sustained operation under conditions that would stress every component of Hollerith's electrical system. Each tabulating machine processed approximately 1,000 cards per hour, with mercury baths maintaining reliable electrical contact through millions of pin actuations. The first major breakthrough came on October 12th, when preliminary population counts revealed patterns that traditional European methods could never have detected at such speed. Hollerith sorting boxes allowed statistical analysts to separate cards into specialized categories and retabulate the sorted groups to produce detailed demographic analysis. German immigrants concentrated in Midwestern agricultural regions, Irish immigrants dominated urban industrial centers, and native-born Americans were migrating westward at rates that challenged every previous population distribution theory. These insights emerged from mechanical tabulation within weeks, rather than the years of manual analysis that European methods required. International attention focused on the Census Bureau's Washington facilities as word spread about the American mechanical calculation achievements. Austrian statistical officials dispatched observers to study Hollerith's methods for their own national count. Canadian government representatives negotiated licensing agreements for tabulating machine production. French census administrators sent technical delegations to examine the electromagnetic counting systems that were producing unprecedented statistical detail. The mechanical reliability that Hollerith had designed into his system was proving itself through continuous international scrutiny. The decisive moment arrived on October 24th, when Census Superintendent Walker announced the preliminary population total, 62,622,250 Americans. European experts had predicted that mechanical tabulation of such magnitude would require at least 18 months, but Hollerith's system had produced accurate totals in less than 5 months of actual processing time. The electromagnetic counters had advanced through billions of individual counting cycles without mechanical failure, validating the conservative engineering principles that prioritized reliability over maximum speed. More impressive than raw counting speed was the analytical capability that traditional methods couldn't match. The tabulating machines processed the same 63 million cards through multiple statistical analyses, occupational distributions by state, age patterns by immigration status, family size correlations with economic indicators, urban versus rural population densities. Each analytical pass required only days rather than the months of manual calculation that European census operations demanded. Statistical relationships that would have remained hidden in traditional ledger book summaries emerged clearly through mechanical cross-tabulation. Foreign governments immediately recognized the revolutionary implications of American mechanical calculation capabilities. Norway's government negotiated contracts for Hollerith machines to process their 1891 census. Russian statistical officials ordered tabulating equipment for population counts across the vast territorial expanses that had previously defied accurate enumeration. The Philippines administration, facing unprecedented colonial census requirements, adopted Hollerith systems rather than attempting traditional European hand-counting methods. Cuba's post-independence government selected mechanical tabulation for their foundational national count. Railroad companies discovered that Hollerith's tabulating machines could revolutionize freight calculation and scheduling operations that had relied on armies of clerks maintaining handwritten ledgers. The Pennsylvania Railroad ordered 12 tabulating systems to process cargo manifests and track equipment utilization across thousands of miles of track. Insurance companies realized that mechanical calculation could transform actuarial analysis by processing policyholder data with speed and accuracy that traditional methods couldn't achieve. Agricultural surveys that had required months of manual tabulation could be completed in weeks using punch card systems. The Census Bureau's financial analysis revealed savings that exceeded even optimistic projections. Traditional European methods would have required over $5 million in clerk wages and operational expenses to process the 1890 census. Hollerith's mechanical system completed the entire operation for approximately $3 million, while providing statistical analysis that would have been impossible through manual calculation. The $2 million savings represented enough funding to purchase additional tabulating machines for expanded government statistical operations. European statistical establishments quietly began adopting American mechanical methods, despite decades of skepticism about machine calculation reliability. British census officials placed orders for Hollerith tabulating systems rather than expanding their traditional clerk operations. German engineering journals published detailed technical analyses of electromagnetic counting principles that they had previously dismissed as mechanically unsound. The theoretical objections that European experts had raised about machine judgment and statistical interpretation dissolved when confronted with actual operational results that exceeded traditional accuracy standards. By December 1890, Hollerith's tabulating machines had processed over 100 million punch cards through the complete census operation without experiencing a single system failure that prevented data processing. The mechanical components, springs, pins, mercury baths, electromagnetic counters, had proven more reliable than the human clerks who operated them. European predictions about inevitable mechanical breakdown had been replaced by international recognition that American engineering had fundamentally transformed statistical calculation capabilities through conservative design principles that prioritized operational reliability over theoretical perfection. The 1900 census approached with European statisticians, predicting that Hollerith's tabulating machines would finally reveal their mechanical limitations when confronted with a decade of industrial growth that had swelled America's population to over 76 million people. German engineering publications suggested that mercury baths would develop oxidation problems after 10 years of operation. British statistical journals warned that electromagnetic counting mechanisms would suffer from metal fatigue that could produce catastrophic failures during sustained use. French census experts maintained that complex mechanical systems inevitably deteriorated through accumulated wear that human oversight could detect but machines could not compensate for. Instead, the Census Bureau's 1900 operation demonstrated mechanical reliability that exceeded even Hollerith's original expectations. The tabulating machines that had processed 63 million cards in 1890 now handled 76 million cards with improved efficiency, as operators had developed techniques for maintaining higher processing speeds without compromising accuracy. The mercury switch contacts showed no signs of degradation after billions of electrical cycles, while electromagnetic counting dials advanced with the same precision they had exhibited during initial deployment. Spring-loaded pins maintained perfect alignment despite millions of card reading operations, and brass contact surfaces remained smooth and corrosion-free. The 1900 operation revealed additional capabilities that original system specifications had not anticipated. Census Bureau statisticians discovered that punch cards from different census years could be combined for longitudinal analysis that tracked demographic changes over time. By tabulating 1890 cards alongside 1900 cards, researchers produced migration patterns, occupational shifts, and population distribution trends that would have required decades of manual analysis using European methods. The mechanical sorting capabilities allowed comparative studies between census decades that generated entirely new categories of statistical knowledge. Railroad companies had expanded their use of Hollerith systems far beyond simple freight calculation. The Pennsylvania Railroad's 12 tabulating machines now processed equipment maintenance schedules, employee payroll records, coal consumption analysis, and passenger traffic patterns across their entire network. Mechanical calculation had transformed railroad management from approximate estimation to precise operational control based on statistical analysis that guided investment decisions and route planning. Similar applications emerged across other industries as managers recognized that mechanical tabulation could reveal business patterns invisible to traditional bookkeeping methods. Insurance companies discovered that Hollerith's analytical capabilities revolutionized actuarial science by enabling precise risk assessment based on vast policyholder databases. The Prudential Insurance Company installed 8 tabulating machines to process mortality statistics, premium calculations, and claim patterns that would have overwhelmed traditional clerking operations. Mechanical cross-tabulation revealed correlations between occupational hazards, geographic factors, and life expectancy that fundamentally altered insurance pricing models. Statistical relationships that had remained hidden in handwritten ledgers emerged clearly through electromagnetic counting and mechanical sorting. The 1910 census provided the definitive test of long-term mechanical reliability as tabulating machines approached their 20th year of continuous operation. European engineering experts traveled to Washington expecting to document the inevitable breakdown of electrical systems that had operated far beyond normal machinery lifespans. Instead, they witnessed tabulating equipment that functioned with greater precision than newly manufactured European mechanical calculators. The original mercury baths maintained perfect electrical conductivity. Electromagnetic coils showed no signs of insulation failure, and mechanical components operated with smooth precision that indicated minimal wear despite decades of sustained use. Agricultural applications demonstrated the versatility of mechanical calculation beyond population statistics. The Department of Agriculture adopted Hollerith systems to process crop yield data, livestock counts, and land utilization surveys that guided federal farming policy. Mechanical tabulation enabled analysis of agricultural productivity patterns across different soil types, climate zones, and farming techniques, with statistical precision that informed scientific agriculture programs. The sorting capabilities allowed researchers to correlate weather patterns with crop yields in ways that supported the emerging field of agricultural economics. International adoption of American mechanical calculation methods had become universal by 1910. European governments that had initially resisted Hollerith systems now operated hundreds of tabulating machines for census operations, tax collection, military conscription records, and industrial surveys. The British Empire used mechanical tabulation to administer colonial populations across India, Australia, and Africa with statistical accuracy that would have been impossible through traditional European administrative methods. German industrial companies employed tabulating machines for production scheduling and quality control analysis that supported their growing manufacturing capabilities. The 1920 census represented the ultimate validation of Hollerith's conservative engineering philosophy as tabulating machines completed their third decade of flawless operation. European observers who had predicted mechanical failure now studied American engineering principles to understand how electrical systems could maintain reliability through such extended periods. The answer lay in Hollerith's original design decisions. No complex timing mechanisms, no precision gears, no high-pressure systems that could create catastrophic failures. Just springs, pins, mercury, and electromagnets operating within conservative performance parameters that prioritize continuous function over maximum speed. Business applications had expanded far beyond original census requirements as companies recognized that mechanical calculation could transform management decision-making. Department stores used tabulating machines to track inventory levels, customer preferences, and seasonal sales patterns that guided purchasing decisions and store layout optimization. Manufacturing companies employed mechanical analysis to monitor production efficiency, material usage, and quality control metrics that reduced waste and improved profitability. Banks adopted punch card systems for account management, loan processing, and investment analysis that enabled precise financial planning. The tabulating machine company, which Hollerith had formed to commercialize his inventions, had evolved into a major industrial enterprise that manufactured hundreds of machines annually for government and business customers. International licensing agreements generated revenue from European, Asian, and South American markets where mechanical calculation had replaced traditional statistical methods. The conservative engineering approach that European experts had initially criticized now represented the foundation of a global industry based on reliable mechanical computation. By 1920, modified versions of Hollerith's original tabulating machines were processing Social Security enrollment, wartime production statistics, corporate payrolls, and scientific research data across thousands of installations. The mechanical reliability that had seemed impossible to European theorists had become the standard for American statistical operations. Not a single tabulating machine had suffered total system failure during 3 decades of continuous operation, validating the engineering philosophy that prioritized conservative design over theoretical complexity. The ironclad dependability that immigrant engineers had built into American mechanical systems was preparing to outlast the inventors who had created them. The 1951 announcement that shocked the statistical world came not from mechanical failure, but from technological graduation. Census Bureau Director Roy Peel declared that the 1950 census would be the last to rely on Hollerith's electromagnetic tabulating machines, as the newly developed Univac white electronic computer could process 1,900 instructions per second, revolutionary speed that promised to transform government data analysis. European engineering observers who had spent decades waiting for American mechanical systems to collapse now witnessed their replacement by electronic marvels that operated at computational speeds unimaginable during Hollerith's era. Yet the transition revealed unexpected truths about reliability that challenged assumptions about technological progress. Univac's installation at Census Bureau headquarters generated enormous publicity as newspapers proclaimed the dawn of the electronic age. The massive computer occupied 1,500 square feet of specially climate-controlled space, contained 5,000 vacuum tubes, and required constant attention from teams of technicians who monitored its operation around the clock. Electronic circuits switched states in microseconds rather than the mechanical seconds required by electromagnetic counters, enabling mathematical calculations that would have taken Hollerith's machines hours to complete. The processing power seemed to represent everything that mechanical systems could never achieve, pure speed unconstrained by physical limitations. Within months, however, Univac's operational reality conflicted sharply with its theoretical capabilities. Vacuum tube failures occurred regularly, requiring technicians to locate and replace defective components that could be anywhere among the computer's 5,000 tubes. Memory errors corrupted data calculations without warning, forcing operators to restart complex processing jobs that might have required hours to complete. Scheduled maintenance shutdowns interrupted operations for cleaning, calibration, and component replacement that mechanical tabulating machines had never required. The electronic wonder that promised continuous operation delivered average uptime of 8 to 12 hours between system failures. Census Bureau engineers quietly maintained several Hollerith tabulating machines in backup storage areas, officially designated as emergency equipment but actually serving as insurance against electronic system breakdowns that could paralyze critical government operations. These mechanical dinosaurs, now approaching their 60th year of operation, continued to process test data with absolute reliability whenever Univac suffered extended downtimes. The electromagnetic counters advanced with the same precision they had exhibited since 1890. Mercury baths maintained perfect electrical conductivity, and spring-loaded pins penetrated punch cards as cleanly as they had during the original St. Louis competition. The engineering comparison revealed fundamental differences in reliability philosophy between mechanical and electronic approaches to calculation. Hollerith had designed his tabulating machines using conservative principles that minimized failure points, simple electrical circuits, robust mechanical components, and operating parameters well within material stress limits. Each electromagnetic counter contained approximately 20 individual parts, all designed for continuous operation over decades. Univac's complexity required thousands of precision components operating at performance limits, where minor variations in voltage, temperature, or timing